Hi students, in today's class, let us discuss about graphical method with the help of linear programming problems. See, this is a linear programming problem, formulation problem. We are doing graph in this problem. See this maximization, and there are three constraints and two variables, x1 and x2 are the two variables. While doing graph, we have to note that there must be only two variables. If there are three variables, we can't do graph. That is x1 one axis and x2 the other axis. If there is another one variable x3, we can't put axis. So only two variable. If there are only two variables, we can do graph. First of all, the inequalities of the constraints, these are the constraints, this is the objective function. The inequalities of the constraints are converted into equations before doing graph. See, x1 plus 2x2 is equal to 2000. x1 plus x2 is equal to 1500. x2 is equal to 600. Let us develop points for these two constraints. This is only one variable and no other, that is x2 is equal to 600 only. So no need to put points. Here there are two variables and equalities are there. So we have to put points for construction of graph. See how to put points. Here when x1 is equal to 0, x2 is equal to, see, x1 is equal to 0. Here 2x2 is equal to 2000. So x2 is equal to 2000 divided by 2 is equal to 1000. Therefore, here the points are 0, 1000. These are the points. In this constraint, we can develop 2 points. Okay. See, when x2 is equal to 0, x2 is equal to 0, then x1 is equal to 2000. Therefore, here the points are 2000, 0. Okay, here x1, here x2, here x1, here x2. So we can prepare a line for this constraint. Then next one, when x1 is equal to 0, x2 simple, x2 is equal to 1500. Therefore, points 0, 1500. Like that. When x2 is equal to 0, see, x1 is equal to 1500. When x2 is equal to 0, x1 is equal to 1500. Therefore, points 1500, 0. Okay, x2 0, x1 1500. No need to put points for x2 is equal to 600. Let us prepare graph with the help of this. Okay, see, this is the axis, x1 axis and x2 axis. We are preparing lines for this constraint and for this constraint and for this constraint with the help of these points. Okay, then see, here the highest value 2000. See points, see the points, the highest is 2000 and the lowest is 1000. So we are starting from 500,000. According to points, we can write the points here. Okay. If the points are very low, that is below 100, then you can put points according to this 0, 20, 40, 60 like that, or small if it is below 50, so you can start with 10, 20, 30, 40 like that. Here very high figure, so we are taking 500,000, 1,500, 2,000, that's enough. Then the first constraint, the first point is 0, 1,000. 0 here, for x1 0 and x2 1,000. See, this is the x2 axis, so put one point here. Then the next point is 2,000 0. 2,000 in x1 and 0 x2. So 2,000 0. Put one point here. Then prepare line by touching these 2 points. Okay, this line called x1 plus 2x2 is equal to 2,000. Okay, then next constraint. The points are 0, 1,500, 1,500, 0. So very easy. 0, 1,500, 1,500 here, 1,500 0, it is here, then put one line. Okay, then this line is called x1 plus x2 is equal to 1,500. Another constraint is only x2 is equal to 600. No need to draw lines like this, only one point. So in x2 axis, find out 600 and draw one line parallel to this x1 axis. So here it is 500, here 1,000. So the middle point is 750. So here x2 600. You prepare this graph with the help of a scale. So correct points we can develop. Okay. Then this is the line x2 600. And then take the feasible region. Actually this is the feasible region. We can put names. Here 0. Then put this point A. There is one point B. Another point C, another point D. Why this is the feasible region? That's another question. The inside region of all the 3 constraints and x1 axis and x2 axis. This is the inside region. See, inside region of x1, inside region of x2, inside region of this constraint x2 is equal to 600. And inside region of this, see this constraint is x1 plus 2x2 is equal to 2,000, this small portion. And the inside region of x1 plus x2 1,500. This is the line and this portion. So this is the inside region. Shade this region. So our feasible region is 0, A, B, C, D. Okay. Then we can develop the solution. See, the feasible region is 0, A, B, C, D. That is, this is the region. Points, we are putting A, B, C, D, 0, A, B, C, D. Then we are developing points for this x1 and x2. See, this is the point 0. Here x1 0 and x2 also 0. Next point is A. x1 0. How? See, it's the x1 0 and x2 here it is 600. So 0, 600. Then B is another point. See, we can find out x1 here. That is, it is near about 750. I have written as 750. It's nearing 750 or just above that. If you are preparing graph with the help of a scale, you can develop points correctly, correct points. See, this is 750, x1 750 and x2, no problem. It lies in the line 600, the point 600. Then C. See here, I am taking it as 950. Okay, no problem. Sometimes just above that or sometimes just below that. x1 950 and x2 500. Okay. Then D. Here x2 is 0 and x1 it is 1500. Then the objective function z is equal to 3x1 plus 5x2. Then multiply these points with this, and this is a question of maximization. Maximize z is equal to 3x1 plus 5x2. This is the objective function here. So this is a question of maximization. Then we have to find out the maximum value here. Here the maximum value is 5350. So Z maximum, we can say that Z maximum at the point C, where x1 is equal to 950 and x2 is equal to 500. Then maximum profit 5350. Then its LPP we have done in our last class. See, there are two dolls. One is basic version doll. In our last class we have discussed about that LPP formulation. In that question it is said that there are two types of dolls, basic version and deluxe version, and profit for basic version is 3 rupees and profit for deluxe version is 5 rupees. If we want to find out maximum profit and how many units of this basic version and how many units of this deluxe version should be manufactured to achieve the maximum profit, if that is the question, we can say that 950 units of basic version and 500 units of deluxe version should be manufactured to achieve maximum profit 5350. So we can write it like that: maximum profit is equal to 5350, x1 950 and x2 500. So we can say that the company should manufacture 950 units of x1 and 500 units of x2 to achieve a maximum profit of 5350. See, another question, that is, it's a case of minimization. How to solve graph if the objective function is of minimization case? See, these are the constraints. See this constraint. This constraint is the inequality is negative. While solving graph, no inequality negative. Here is the negative, it is negative 2. So to convert it into positive, this figure into positive, we have to change the signs from here. See, minus 2x1 plus x2 less than or equal to 2. then it becomes positive. After that, we can change the inequalities into equations. Before doing graph, all the inequalities of the constraints should be converted into equations. See, minus 3x1, 4x2 is equal to 12, minus 2x1 plus x2 is equal to 2, 2x1, 3x2 is equal to 12, x1 is equal to 4, x2 is equal to 2. Okay, then we can develop points for these three constraints. No need to develop points for this one, a single, here only x1 and here only x2. See, here when x1 is equal to 0, see, x1 is equal to 0, 4x2 is equal to 12. So, x2 is equal to 12 by 4, 3. Therefore, points 0, 3. Next one, when x2 is equal to 0, see, x2 0, minus 3x1 is equal to 12. Therefore, x1 is equal to 12 divided by minus 3, it is minus 4. Therefore, points minus 4, 0. These are the 2 points of this constraint. Next, when x1 is equal to 0, x1 0, x2 is equal to 2, x2 is equal to 2. Therefore, points 0, 2. Next, when x2 is equal to 0, see, x2 is equal to 0, minus 2x1 is equal to 2. Therefore, x1 is equal to 2 divided by minus 2, it is minus 1. Points minus 1, 0. Okay, so 2 constraints over. Then third constraint, when x1 is equal to 0, x2 is equal to 12 by 3, it is 4. Therefore, points 0, 4. Again, when x2 is equal to 0, then x1 is equal to 12 by 2, 6. Therefore, points 6, 0. Okay, these are the points. See this graph, that is, here the highest point is 6. So, we can write 0, then 6, here also 6, here negative 4. So, x1 in the negative side. So, minus 1, minus 2, that is in the point minus 1 and minus 4 is there. We are plotting that also. Then, let us start. First of all, first constraint, first point, 0, 3. Okay, 0, 3. 0, x1 0, x2 3. Its connection, x1 minus 4 and x2 0. So, here is the point. Let us prepare line, but you have to continue this line. Why? That is, you can find out the feasible region here, not here. If we cut this line by this point, you can't find out the feasible region. You need this line also for finding out the exact feasible region here. So this is the line. Then next one is 0, 2. Okay. Then minus 1, 0. Here also you continue the line like this. Okay. Then it is 0, 4 and 6, 0. Then 0, 4 and 6, 0. 4 in x2 axis and 6 in x1. So, see. Then the next 2 points. x1 is equal to 4. So from 4, you can draw a line like this. And x2 is equal to 2. From 2, you can draw a line like this. Then you have to put the constraint name. Here, this one is minus 3x1 plus 4x2 is equal to 12. Then minus 2x1 plus x2 is equal to 2. Here it is 2x1 plus 3, 2x1 plus 3x2 is equal to 12, and x1 4 and x2 2. Okay. Where you can find the feasible region? See here. Here the feasible region is this one. But here, if this is the feasible region, this line and this line out. Other lines okay, these 2 lines out. So you have to take the region which is inside of all the constraints. See, this is the region. See, here the point, we can put the point A, here it is B, here it is C, here it is D, here it is E. But in this feasible region, there is no touch of x1 axis and x2 axis. But this is a constraint, and this line is parallel to x1. So inside of this line. And see this line, this is from x1 and this line is parallel to x2 also. So you can take this feasible region for this. Okay. Usually in minimization case, we can find out the feasible region towards that outside side. That is, in minimization case, usually the feasible region outside, not inside. This is somewhat outside, away from this x2 and x1. Usually this happens in minimization case because you can develop a feasible region here or here because you need to touch all lines. Okay, so the feasible region is A, B, C, D, E. A, B, C, D, E. Okay, same as the previous question. Points that x1, x2. x1 in the point A, there is x1. We are taking as 0.75, x2 3.5, then B, C, D, E. Multiply here here we have to take the minimum value because this is a minimization case. In the minimization case, minimum cost. So we can write it as Z is minimum at the point E. See, it is 17.5 minimum of this, where x1 is equal to 2.5 and x2 is equal to 2. Therefore, minimum cost is equal to 17.5. So this is the minimization case graph. Now our graphical method, two versions, that is maximization case and minimization case comes to an end. So let us discuss this simplex method, two versions in our next class. Okay, thank you.